All right, welcome back everyone to Velicon 2022. Hope everyone enjoyed a nice refreshing lunch break or dinner break or even a breakfast break wherever you may be in the world. We still have a loaded second half to get to. It'll be just, the format will be similar to the first half of the day, right? We'll have 3 presentations in this first session. We'll have a break and we'll have another 3 in the final session of the day, and then we'll wrap it up. So with that, turn it over to Wes again, who you guys have all met in the first half of the day. And he's going to be talking about using DinoSOARLab to uncover adversary actions and orchestrate rapid response. Wes, take it away.
All right, thank you. Give me just a moment to share my screen here. Find it. Screen 1, screen 2. Share and this. Go ahead and start my video and get this ball rolling. Beginning. So let me know. Look good on your side?
Yes, looks good.
All right, thanks, sir. All right, as mentioned, my name is Wes Lambert, and I am the principal engineer at Security Onion Solutions. I wanted to talk to you guys today about DinoSOARLab, which is another project that I've worked on. It's somewhat similar to Velociraptor maybe in some of the technical integration and that sort of thing, but just wanted to give an alternate perspective of some of the additional data or context that we might have from using something like DinoSOARLab to learn about that and to experiment with these different tools. So that's what we're going through right now. All right, so what is DinoSOARLab? It's previously named SOARLab. It's been a project that I've worked on for a little while. I've not had as much time to update as I would like. I did change the name though, based on some great user feedback from some folks on Twitter. I thought it was a great name, so I figured I'd go ahead and stick with that for Velicon. But it essentially is a Docker-based project that allows you to tie together all these different open source or free and open tools to really learn about how we can enrich data, perform response actions, and kind of orchestrate our operations or security operations. Again, it's going to be similar to the previous talk, but there will be some key differences in this. So a little bit of context, I mentioned previously, I put out an article about tying together Security Onion, the Hive, N8N, and Velociraptor a while back, maybe I think it's really a couple of years now, but it was really about, again, integrating those free and open tools for detection, the orchestration and response, kind of showing folks how they might leverage these tools in their enterprise, tying these different things together, doing different, performing different actions, getting different context, increasing context around data. So this is really based off of that with some architectural changes based on how Security Onion has changed and things like that. So we'll get into that and get into the components here. Now, obviously, as with the other, Velociraptor is one of the core components here in this particular setup. We've got that for the host-based forensics, the monitoring and response, obviously the cross-platform awesomeness, and the super flexibility of Zeek, right? But aside from that, one of the other big components is Security Onion. And I'm not sure how many folks on this webinar and this conference have used Security Onion before, but it's been around for a while. It's one of the kind of, in my opinion, de facto free and open platforms for intrusion detection, log management, enterprise security monitoring. There's things like host-based monitoring from the native capabilities like and then full packet capture as well. And then on top of that, similar to a lot of other, SIEMs or log management platforms, there's that ability to ingest a bunch of different log types, have those parsed, and have those, have context, right? Because a lot of times we get this information, these logs, and we throw them in this place, and we don't get a ton of context. Really, the whole idea here is to make it easier to pivot from one data source to another, to be able to get the context you want quickly, and to go from there and speed along your investigation, right? So the quicker we can get that context, the quicker, hopefully we can come to a determination on what's happening with our within our environment, and how we can scope it within the environment. So again, one of the main components within Security Onion for Suricata, for network-based intrusion detection is going to be Suricata. It generates those NIDS alerts. It can also generate network metadata. So if you're familiar with Zeek in the sense that it generates activity for connections, HTTP traffic, etc., Suricata can also do the same now. So there's an option to do either or in Security Onion. And then obviously it uses rules to identify suspicious network traffic. Those alerts are generated and then ingested into Security Onion, and then we can act on them and gather more context as we need to. Here's an example right here just of some alerts in the alerts pane within Security Onion. Again, this is not all about Security Onion, but I just want to kind of get through some context here. Similarly with Zeek, it can record network metadata. I mentioned HTTP and connections. There's also DNS data, right? Things, Security Onion is passively listening to the network traffic, then writing this network metadata that we ingest into the main stack. Things like SMB data, SMTP traffic, right? And then even file extraction, stuff like that. Both Zeek and Suricata can support pulling files from the network down, right? And then we can act on those with additional scripts or additional tools. So they're both very capable at doing that. Additionally, there's the ability to have full packet capture with Security Onion, right? So regardless of the network metadata being generated, we can see a raw capture of that traffic, which is very useful, except when you're in situations where you're monitoring encrypted traffic, right? A lot of times we might have to filter that capture out, but otherwise, when getting in between those encryption layers or mechanisms, we do have that available to us for that additional context. Now, here's just an example of a stream that we followed in Security Onion. There's a native way to view PCAP in the web interface. And then for those files that we interact with or that are extracted from the network, there is an application called Strelka, which is an open source file-oriented detection framework. And it uses a bunch of different scanners to get to generate different metadata about files and to give you, again, more context, right? But it analyzes those files extracted from the network and then applies those scanners, and then can also apply Yara to it, since Yara is one of the scanners. And I'll get to where I'm going with this in just a moment. Additionally, there is the capability to generate your own cases within Security Onion. So it's a great way to track activity if you're going through an investigation and then attaching different indicators or observables for follow-up later or for investigation now, right? It's a great way to do that. But this is not a Security Onion only talk. SOARLab also includes N8N, aside from Velociraptor, which is a free and open low-code automation platform. It's similar if you've messed with Node-RED. It's similar to Node-RED, similar to Shuffle, except Shuffle is a little bit more security focused. But just another one of those low-code automation platforms that really has a ton of different triggers and operations available to us to be able to act on that data, or to be able to respond how we want, right, and process data. So really the summary here, and I think I've got a duplicate slide there. The summary here is there's a few different components working together within this concept or within this project to essentially have this network traffic tied together along with this host-based traffic or this host-based artifacts, right, or results from running artifacts in Velociraptor, and then being able to perform some action in between the two to help identify additional context or to perform response in a somewhat automated fashion. So, kind of getting more into the meat of it and more what it looks like in the actual lab. Setting up the lab is pretty straightforward. I try to make it always pretty simple. So if you want to set up the lab, you just need a running instance of Security Onion. You can, if you already have Security Onion running in your environment, you can install this on top of it. And the same, if you go and download it and run setup, you can install this on top of it. And what it's going to do is set up on top of security, and then it's going to set up N8N and Velociraptor, and then some other customizations to allow us to do things a little bit more easily. But yeah, so it's pretty straightforward as far as the install process, and I'll just leave that there. But how do we actually leverage it? Like, how's it even useful from a learning standpoint, or from thinking about how we might approach these same operations in our environment? So one thing I mentioned is that gathering additional context, right? Comparing activity across host and network based data, right? We have this data from Velociraptor from this host collection that we collected, or just the fact that this was on this host, right? And then we have a client ID associated with that, and maybe a host name or IP address. Being able to correlate that back to the network stack can be advantageous, right? I mean, it might not always be one-to-one as far as IPs, but generally something like host name, might be pretty analogous, right? So we can do that for things like connections, for things like protocol-specific events, for alerts, right? Tying back the host that Velociraptor is installed on to the network traffic, and doing some correlation from there. And here's an example just from the security NN perspective in this is called Hunt. This is an interface in security NN where you can search the data similar to Splunk, where we're just looking at the different types of data here. And we can see that we've got some different data from Zeek. We got some different data from Velociraptor, from OSSEC, all relative to the same IP address that is associated with this particular client, right? So, and we can do that based off the client IP or the source IP, just however it's defined when it's parsing. And we can also do this off of host name, right? So that's a great way to be able to, really validate something that happened on the host, or take something from the network perspective and then go to the host, right? Pivot to Velociraptor and go do some collection there, dig further, right? We want to dig deeper. So that's a great way to do that. Here are some examples of just looking at some different artifacts across clients, maybe just what's been run. Just kind of a fun little way to demonstrate that from the Hunt interface. And then here is another way I mentioned pivoting, that we can leverage that context, right? So for example, we're investigating, or we're doing some threat hunting, or we're looking at events in security NN, and then we see this client ID over here. It's hidden in this right here, but this is what I clicked, and then it brings down this context menu here, and we can click right here to go to Velociraptor, right? This is one of the customizations of this SOARLab integration. So if I click on this, then now I can be transported already over to Velociraptor. It's a fewer clicks than me going and typing in Velociraptor or doing something else. It helps with, maintaining the stream of thought in your brain, and it just helps, overall, just from a more streamlined process, right? So then we can go dig into that host and go, run artifacts, and then, we could even come back to security NN later and then review the results of those artifacts and correlate that with other activity in there, other network activity, right? So it's just another great way to leverage that integration with the two of those. Similarly, if we wanted to come from Velociraptor over to security NN, right? Maybe we're in the results from we're in a notebook, or we're in the results from a Hunt or something else, and we want to go look up what this client has been doing in security NN. We can do that as well. Now with the new context menu available in Velociraptor, we can pivot to security NN from Velociraptor. So we can go back and forth as needed, getting that additional context that we all crave as analysts, as incident responders, and then be able to go from place to place as we need to and get that additional information. Excuse me, let me get some water here. All right, so another way. I mentioned Strelka before. I mentioned the fact that it can run Yara, right? So this is kind of a cut up alert, because from security NN, it's kind of cut up because it wouldn't all fit on the slide. But you can see here, we've got it. It came from Strelka that it's an alert, right? We can see the rule. you can see that this detects a batch file that has been obfuscated using variable substitution, like a bunch of it. And the rule name here and the score. Let me get some other hashes for the actual file that was analyzed. So basically what happened was this file, either somebody downloaded it, right, or it was transferred across the network somehow. And then Zeek or Suricata saw that. And then after it extracted the file, Strelka analyzed the file, ran Yara against it, and now we know that this, occurred in our network, right? We can see some IPs or something else, right? We can see some other activity associated with it, but we might not have much more additional context, right? It might not be that easy to scope, right? Exactly who has this file or where it went or whatnot, right? So here's that rule again, just kind of getting into what it looks for. It's a very simple rule. Again, it was slightly modified for the purpose of this demonstration for DinoSOARLab, but again, just looking for that obfuscated batch file. So what we can do from here is, if you see here, we've actually clicked on this alert and we've escalated it to a new case within Security Onion. And then from there, we can do things like add additional details, add observables, right? We've got a kind of a description of the case here where it's been escalated, and we've added this particular observable right here, which was the file hash. If we go back, the MD5 from right here. Now, obviously, if we wanted to modify some things in the pipeline, we could use any of these that we want, but for the purposes of the demonstration, we chose the MD5, and we've attached that as an observable, can't talk, to the case, right? So now from here, we might go off and do additional investigation, right? We want to figure out how this is, where this is in our environment, which host this might have been transferred to, who else might have downloaded it. Now, if we look here, what's actually happening once we attach this to the case is we have a last alert running in security and in the background. So if I'm adding I've added a custom rule here to where it looks at any observables that I've added to a case. And then if they meet a certain condition, then it'll go off and send them to this webhook right here. And what is running at this webhook is actually innate-in. So what happens here is that this webhook receives this call from a last alert. We're routing by the observable type. If it was a hash, we're doing a hash hunt. If it was a file name that we're searching on, we're performing a file name. In this instance, the ElastiAlert rule fired and it was a hash. So it kicked off the hash hunt here. And if we go to Velociraptor, similar to the previous demo, we now have a hash hunt generated, right? From this observable, it's going across, it's searching every single endpoint that Velociraptor is enrolled in, right? Or that's subscribing to the hunt. And then we can see here that we have this one hit, right? We have one row returned for this particular client right here. This is the intimate details of this particular flow right here. But that one client that we have connected, we saw had it, right? We've confirmed that this hash did exist on there, so that file is likely present on the box. And what we've done now is, instead of trying to go search, a bunch of places, in Security Onion or go manually elsewhere, we've leveraged, the best capabilities of these platforms to go off and automate the scheduling of this hunt, and then get that context that we're looking for, right? So Velociraptor is doing all the heavy lifting. It's in this instance, right? We're sending it, we're saying, hey, go search for this hash, and then it's running. And then at the same time, we're also going to be quarantining hosts who return results for the hash or the file name hunt, right? And this is a modified version of the Windows artifact, the quarantine artifact. And what it's looking for here is looking for any file name or hash hunts that have returned with any results. And if a client did return for that result, it will quarantine that host. And so we see this here with this particular host, right? We'll see that this basically met the criteria right here. We'll see the local hashes query here and the hunt that had created the run or the flow, right? And then the fact that it then later came back and was quarantined because of that server artifact that was running. Right now, we could customize this a bunch of different ways, right? I mean, there's a lot of different ways that you could change this. You could have Velociraptor completely handle the event handling, right? You don't necessarily need N8N or some other intermediary, but it's just a nice way to kind of think about how you might interact with different systems and think about how you might process and manipulate that data coming from the source system like security engine. But yeah, I mean, all of this, all the integration is completely also doable within Veequl itself, which is, I think, predictable. Presented last, what was it, at the Velociraptor artifact competition, was a great example of a lot of automation and a lot of kind of management functions from the Veequl perspective. So as far as the as far as going through the demo or anything else, that is all that I have at this time. It ended up pretty brief. I think in the future, though, for this particular project, I will probably be replacing Shuffle with N8N to be able to tie in with some other security appliances or other security software. And I want to look into some more integration with security and Velociraptor a little bit more closely, right? Think about how else we can tie together that context and orchestrate those actions, swiftly and in an efficient fashion. So unless you guys have any questions, I think I actually have one more slide. Yeah, I do. Okay, so here's the summary here. Again, just a summary of the data flow. So in the example, we created that case and attached the IOC. And then Elastalert, along with security engine, was looking at that, right, checking for those IOCs or checking for those indicators or observables, and then hands that off to N8N, which then in turn hands it off to the correct Velociraptor hunt. Again, completely automatable from the Velociraptor perspective, but hopefully this helps to kind of get you going in some particular direction with experimentation or anything, things like that. But yeah, if you have any feedback or any other questions, please feel free to let me know via Twitter or via the GitHub. All the details are right there. And I think that is all I have for you guys for today for this particular demonstration.
All right, thanks a lot, Wes.